Hello everyone from Math 1435, Pre-Calculus 2. It's Professor Wenson here again with a video on your KnewtonAlta homework, Section 8.2, Part 2. It's titled Graph, Secant, and Cosecant Functions. So we've seen the graphs now of sines, cosines, tangents, and cotangents. Now hopefully you're familiar with the graphs of the sine and cosine functions. Remember those waves, those wavy shapes? Because the graphs of the secant and cosecant functions, I'm going to show you how to develop those using the graph of a sine or cosine function. All right. So let's get into it. Alright, so here I am in the again, you're not going to see the word preview for section 8.2 part 2. You got your objectives. There are 4 of them in this particular section. So graphing, secant functions, finding, graphing cosecant functions, and then finding the equation of a secant or cosecant function from its graph, which you're going to see again. You're going to see how finding equations for secants and cosecants are going to be very related, very similar to how we found the equation for a sine or cosine graph back in section 8.1. Alright, so I'll start off with, now I'm not going to, what I'm going to do is I'm going to do the instruction on my own. Right, you can click on more instruction, of course, for every objective and see how they do things. Right, I'm going to do it kind of my own way, the way I prefer. And you decide, I guess, which one you like better. Do you like my way of graphing with the key value method, or the way they show? Whichever one. They both work. They both end up with the same results. All right, so what I'm going to do is go into some paper here, and we're going to start off. Now I know it's titled secant and cosecant. I'm going to start off with the cosecant function. Y equals the cosecant of x. That was that CSC. And hopefully you recall from an earlier, from chapter 7, that the cosecant of an angle, say theta here, is the reciprocal of the sine of that same angle. Alright, so the cosecant of an angle theta is 1 over, or 1 divided by, the reciprocal of sine of theta. Alright. So what I have over here, and you could go on with more special angles if you wanted, but what I have over here are the special angle measures, from 0 to 90 degrees or 0 to pi over 2 radians. These were angle measures that if you drew them in standard position would be in quadrant 1. And hopefully you remember these values. And I brought these up in section 8.2 part 1 as well. Remember, the sine of 0 was 0. The sine of pi over 6, 30 degrees, was a half. The sine of pi over 4, or 45 degrees, was the square root of 2 divided by 2, which is the same as 1 divided by the square root of 2. You want to think of it that way as well. And then the sine of pi over 3, or 60 degrees, was the square root of 3 divided by 2. And the sine of 90 degrees, or pi over 2 radians, is 1. So noting all this, and the fact that cosecant of an angle is the reciprocal of the sine, we can state the cosecant of all these special angles from quadrant 1. All right, so if the sine of 0 is 0, then the cosecant of 0 is the reciprocal of 0, 1 divided by 0. Can't divide by 0, right? So remember, you've seen this, you saw this in the tangent and cotangent video, right? When you're dividing by 0, that's an undefined operation. This has no value. Okay, so the cosecant of 0 is undefined. All right. The sine of pi over 6, right? The sine of 30 degrees is a half. So the cosecant of pi over 6, or the cosecant of 30 degrees, is going to be the reciprocal of a half, which is 2. The sine of 45 degrees, pi over 4 radians, is, the square root of 2 divided by 2, or like I said here, 1 divided by the square root of 2, same thing. Just flip that over for the cosecant. All right, so the cosecant of pi over 4 radians, or 45 degrees, is just the square root of 2. The sine of pi over 3 was square root of 3 over 2. So the cosecant of pi over 3 is the reciprocal of this, 2 divided by the square root of 3. Or if you rationalize, it's 2 times the square root of 3 divided by 3, right? Or 2/3 of the square root of 3. Right. And finally, to end this, from 0 to 90 degrees here, 0 to pi over 2, the sine of pi over 2 is 1. The cosecant of pi over 2, right, is also 1, right? The reciprocal of 1 is 1. And again, you can do this for all the special angles. If you go from 0 to 2 pi, you go once around, look at your unit circle if you want. Remember, the y coordinates are the sines. You can get your cosecant values. Alright, so then I can start drawing a graph on the xy plane of the function, y equals the cosecant of x. So I'll keep these values up. Here are all these cosecants I just drew here. And we're going to start graphing. And now this is one way I'm going to do it. Another way I will show you is actually kind of also a way they show you in your KnewtonAlta, in the more instruction there. Y equals the cosecant of x. Right, y equals cosecant of x. Alright, so again, I'll pull up, let's try to keep that on screen, and I'm going to draw an x-axis and a y-axis here. So x-axis horizontal, and y-axis vertical. And I'm starting off right with those quadrant 1 angles. Quadrant 1 angles. So starting off with 0 here, and then let's say this distance is pi over 2. Right? So there's 0 to 90 degrees. I cut that in half. That gives me 45 degrees, or pi over 4. And then I'll try to break this from 0 to pi over 2 into thirds. So maybe here and here for 3 equal pieces, from 0 here, then between these two, and then that's every 30 degrees, pi over 6, and then 60 degrees, pi over 3. Right, and then the outputs, right, now remember, undefined. You saw this with the tangent, right? The cosecant of 0 is undefined. When that happened, you had a vertical asymptote, right? So I'm going to do that on the y-axis here. Right? So at x equals 0, I'm going to draw this like dotted line. Remember, this is a vertical asymptote. Right? So the graph, remember, near a vertical asymptote, remember the graph is going to either go to infinity, go up forever, or down forever, right? Approach infinity or negative infinity on either side of these vertical asymptotes. All right, then the outputs, pardon me, the special output showing up over here. You have, 1, 2, square root of 2, 2 times the square root of 3 over 3. Alright, so let's say this is 1 unit here on the y-axis, and if that's 1 unit, then this is 2 units. Alright. And the square root of 2 is about 1.414, a little under 1.5. So here's 1.5, and say this is the square root of 2. Alright, right there, about 1.4. And then 2 times the square root of 3 over 3 is about 1.16, I believe. Let me pull up a calculator and double check that. So 2 divided by the square root of 3. All right, 2 times the square root of 3 divided by 3, or 2 divided by the square root of 3, 1.15. Right. So this is 1.4-ish, 1.15, maybe about here. Okay, so there's 2 times the square root of 3 divided by 3, just a little bit above 1 there, 1 1/10. All right, so let me get rid of the calculator. All right, so those are all the special values showing up. All right, then what we're seeing is when we plot some points. The cosecant of pi over 6 is 2. There. The cosecant of pi over 4 is the square root of 2. The cosecant of pi over 3 is 2 times the square root of 3 over 3. And then the cosecant of pi over 2 is 1. All right. And as I was saying, now you might see where it's going here. As I get closer and closer to 0, you see how this is following these dots, the graph is going to be going up toward infinity. Right? Again, on that side, on the right side of the vertical asymptote. Again, let me show you on the calculator. Okay, I'll put in now the cosecant, remember, is the reciprocal of the sine. So on the calculator, I have to do 1 divided by sine. Now, I'm going to go to degree mode here. Make sure I'm in. Alright, so I'm already in degree mode. I know these are radians, but I'm just going to put in some degrees. So let's take, let's plug in values that are close to 0 degrees and see what happens. Right. So we saw that the 1 divided by the sine of 30. Right, when I plug in 30 degrees, I'm getting 2. Right. So pi over 6, 30 degrees gives me an output of 2. Go even closer to 0. 1 divided by the sine of 10 degrees. Now, according to my graph here, it should be even bigger than 2. Right? It should have a larger output, and see it's 5.7 whatever. Get even closer to 0. How about 1 degree? 1 divided by the sine of 1 degree should be even larger. See, it's 57 something. How about really close to 0? Right? And again, the closer to 0 I get from the right here, the larger and larger my cosecant value is. Right? 1 divided by the sine of, say, 0.00001 degrees. Right? Very, very small value. And you see how large that is? Huge number, 5,729,577.951. So it gets as large as I wish. I just have to get closer to 0. And if I took the cosecant of 0.0000001 degrees or radians, something really, really tiny, give me an even larger value for my output. All right. So there's from 0 to pi over 2. All right, now what I'm going to do next is go from pi over 2 to pi. All right. So 0 to pi over 2. Here's pi over 2 to pi. Trying to keep that about the same. And these will represent angles that, if drawn in standard position, would be in quadrant 2, right? Which would still have positive cosecants, right? Because the sines would be positive, right, in quadrant 2. So cosecants would still be positive. And I'll cut this in half. Now that'll be 90 plus 45, 135. That'll be 3 pi over 4. And then break this into thirds. You got to do like that. And that's 2 pi over 3 or 120 degrees, and then 5 pi over 6 or 150 degrees, right? Some special angles. And I get these same outputs, right? Because they all these angles I just marked off here have the same reference angles as all the ones I marked off in quadrant 1. So the cosecant of 2 pi over 3 would just be 2 root 3 over 3, right? In line with that one, pi over 3. The cosecant of 3 pi over 4 would be the square root of 2. Because this has got the same, it's got a reference angle of pi over 4. The cosecant of 5 pi over 6 would be 2. And it's got a reference angle of pi over 6. And then the cosecant of pi, now remember the sine of pi was 0. So the cosecant of pi is undefined. Right? So I put another vertical asymptote here. And then again, you see the graph doing this thing, approaching infinity on this left side of pi. Right? So I get this nice like U shape here. Right, nice little U shape. All right, now that was from 0 to pi. Now what about pi to 3 pi over 2? What about there? Now pi to 3 pi over 2. If you were in degrees, that'd be 180 degrees to 270 degrees. Those angles are in quadrant 3. Now in quadrant 3, if you were drawing angles in standard position, in quadrant 3, remember the y coordinates are negative. So the signs would be negative, meaning that these cosecants would be negative. Right, so let me draw that. So here's pi over 2 to pi. Here's pi to 3 pi over 2, right, the next quadrant. And I cut this in half. That'd be 5 pi over 4. And try to break this into thirds every 30 degrees here. That'd be 7 pi over 6 and 4 pi over 3. And again, the special angles that show up there. But now all the outputs will be negative. So all these values here, but negative, right? So negative 1, negative 2, negative square root of 2, negative 2 root 3 over 3, negative square root of 2, right? All negative. All right, so the reference angle for 7 pi over 6 would be pi over 6. So you'll have a value of 2, but negative. So the cosecant of 7 pi over 6, negative 2. 5 pi over 4, negative square root of 2. 4 pi over 3, negative 2 root 3 over 3. And 3 pi over 2, negative 1. Remember the sign of 3 pi over 2 was negative 1, so the reciprocal of that's still negative 1. And you see, this is like, up here you got like a U shape opening up. This is the left half of a U shape opening down. The graph will approach, negative infinity on this side. And I'll show you some examples on a calculator. Now I'm in degree mode, right? So this is 180 degrees. If I put something in a little bit more than 180 degrees, I'll get a big negative output. All right, so let's see, 1 divided by the sine of, say, 180, 0.001, right? Something barely bigger than 180 degrees. It should be some big negative number, say negative 57,000. And the closer I get to 180, 180.0001, 00001, I get bigger and bigger negative values. Okay. All right. Then finally, that was from pi to 3 pi over 2. Representing the quadrant 3 angles in standard position. Let's go 3 pi over 2 to 2 pi. Let's say that ends over here, right? So there's 2 pi. And break this up, halfway would be 7 pi over 4. Then break into thirds, and you have 11 pi over 6 on this side, 330 degrees, and 300 degrees, 5 pi over 3 here. Again, following the, so you're going to have this U shape opening down. Right? The cosecant of 5 pi over 3 would be negative 2 root 3 over 3. 7 pi over 4 would be negative square root of 2. 11 pi over 6 would be negative 2. And then the cosecant of 2 pi, well, 2 pi, you're right back at where you were with 0, right, is undefined. Right? You're dividing by 0. So I get this graph, approaching negative infinity again on that side of the asymptote. So you're getting this U shape opening up between 0 and pi. You're getting this U shape opening down between pi and 2 pi. And then this picture keeps repeating, because once you're at 2 pi, it's like being back at 0, right? You're starting over again. So here's one, so the period, right? The period of the cosecant function is 2 pi, right? So we're back to having a period of 2 pi. Remember tangent and cotangent had a period of 1 pi? Well, those are the only two functions that have a period of 1 pi, right? Tangent and cotangent of x. All the other ones, sine, cosine, cosecant, and you'll see later also secant, have this period of 2 pi yet again. Right? So we're back to 2 pi, repeating every 2 pi. Right, and then this picture, so this picture with the u up, u down will repeat over and over and over again. And I'll show you with a better picture of this on the Desmos website. So here we have y equals, cosecant of x. And you see this u up, u down, u up, u down, right? It's just alternating these u up, u down shapes. And notice there's a big gap between them. Notice that there is a big gap between them. All right, and what we're going to be doing to help us find equations for these graphs is we're going to fill the gap between with a sine function. Look at y equals the sine of x. See how it kind of fills the gap between these u shapes? See, there's sine x, that sine wave, and then the green graph is the reciprocal of that, right? Kind of turning the sine wave outwards. All right. We're going to use sine and cosine waves to fill the gap between these u shapes for cosecant and secant. All right. Okay. All right, so period's 2 pi, and let me state some other properties. All right, in fact, let me draw in some more stuff here. So if this is 0 to 2 pi that way, let's say this is 0 to 2 pi, this 0 to negative 2 pi this way. All right, and I'll draw one more cycle here. I'm going to cut this in half, and I'll just do the key values. So negative pi over 2, negative 3 pi over 2. I'm just going to go every 90 degrees, every pi over 2 here. Now, if this picture truly repeats, right, you'll have an asymptote at negative pi and at negative 2 pi. And the value at negative pi over 2 should be the same as the value at 3 pi over 2, right? Those are 2 pi apart, so negative 1. And the value at negative 3 pi over 2 should be the same as pi over 2, because those are 2 pi apart, so positive 1. And again, this picture I drew here on the right half of the page should repeat. So I'll have this like U shape opening up between these two asymptotes, and then this U shape opening down between these two asymptotes. Same picture again. All right. And there, now I've just drawn 2 cycles, 2 periods worth of the cosecant graph. And like I said earlier, notice the gap between them. Right? There's a gap between them that we can put the sine function into if we wished. Right? Like right here. Everywhere there's an asymptote will be an x-intercept of the sine graph. Everywhere there's an asymptote is where an x-intercept of the sine graph will be. And at the bottom of one of these U-shapes for a cosecant will be the top of a hill for the sine. And at the top of a hill for the cosecant will be the bottom of a valley for the sine. So like here would be a graph of the sine function in pink here from negative 2 pi to pi. So like there's y equals the sine of x, as I drew on the Desmos website. All right, there should be a space between these. Right, these U shapes don't overlap. There's a gap between them that you can fill with a sine wave or a cosine wave when we talk about secant. All right. Okay. Now some other important stuff here about the cosecant function, and then we'll get into very similarly the secant function. And I'll show you the other way around. Well, I'll graph cosine first and then show you what secant looks like. So for cosecant, right, y equals cosecant x. The domain, what you can plug in for x, is all real numbers. You can plug in anything except certain values, right, where the asymptotes are. All real numbers except, now notice where these asymptotes are, where the cosecant is undefined. At 0, 1 pi, 2 pi, 3 pi, negative 1 pi, negative 2 pi, negative 3 pi, basically every pi, every multiple of pi. So except multiples of pi. All right. The range. Right, Now the range I'm going to put in interval notation. Now the range, look at the purple, again, the purple graph, right? Don't look at the sign, don't look at the sine wave. Look at the purple graph, right? The cosecant. See, if I go from the top, bottom to top here, on the look at the y-axis values that are being used. See, I got everything from negative infinity up to negative 1. Up to negative 1. So I have everything from negative infinity up to negative 1, including negative 1, right? This point has a y-coordinate of negative 1. This point has a y-coordinate of negative 1. Then there's a gap, a space. So I'm doing the union. Right? Then there's a space, right? Between negative 1 and positive 1, there's a gap. There's nothing on the purple graph. Right? Nothing on the purple graph. And then it starts up again at y equals 1, and then goes up to infinity. So from 1 to infinity, including 1, and always parentheses on infinity. So the range is values up to negative 1 in union with the values 1 or greater, but nothing in between. All right, and then one other thing you might notice, looking at the purple graph again, that you have origin symmetry. Right? If I take a point, go to the origin, go the same distance across, you land at another point on the graph. If you reflect through the origin, you get the same graph again. So this is another odd function. Has origin symmetry, meaning that the cosecant of a negative angle is the opposite of the cosecant of the positive angle. Right. So far our odd functions have been sine. Sine was odd. Tangent was odd. Cotangent was odd. And now cosecant. All right, so you have 4 odd functions: sine, tangent, cotangent, and then the reciprocal of sine, cosecant. Okay? All right, so that was the graph of the cosecant function. Now, in a very similar fashion, I'm going to use the cosine wave. I'm going to use the cosine wave to show you the graph of the secant function. Now, I'll give you a few values here. All right. These are just the first quadrant values. So these are cosines. Remember, cosine of 0 was 1. Cosine of 30 degrees, or pi over 6, is the square root of 3 divided by 2. The cosine of pi over 4 was the square root of 2 divided by 2. The cosine of pi over 3, or 60 degrees, was a half. And the cosine of pi over 2 was 0. Alright, so we can tell you what the secants are. Remember, the secant of an angle, secant was the reciprocal of the cosine, 1 over cosine. So the secant of 0 is 1. The secant of pi over 6 is 2 times the square root of 3 over 3. Right? Flip that, 2 divided by the square root of 3, and then if you rationalize that, remember this was approximately 1.15. The secant of pi over 4 is just the square root of 2, right? Something about 1.414. The secant of pi over 3 is 2. Right, the reciprocal of a half. And then the secant of 90 degrees, pi over 2 radians, is undefined. Right? The cosine is 0. 0 does not have a reciprocal. So I'll have an asymptote at pi over 2. Right? So I'll make a really short version of this graph here, and then I'll do a bigger one on the next page. So for this first quadrant angle, these first quadrant angles, 0 to pi over 2, we got pi over 4 and pi over 6, pi over 3 here. And the outputs, there's 1, 2, square root of 2, and then 2 root 3 over 3. And the the secant of 0, 1, pi over 6, 2 root 3 over 3, pi over 4, square root of 2, pi over 3, 2, and then an asymptote at pi over 2. And you get this, like the right half of a U shape. And you see how this is looking similar already to the graph of cosecant, right? You got these U shapes. So there's going to be a U shape opening up and then a U shape opening down between sets of asymptotes. Alright, so let's see where these asymptotes would be by looking at, remember, this is the reciprocal of the cosine function. I can really easily graph a secant function by looking at a graph of a corresponding cosine function. All right. So again, here's xy coordinate plane. Now I'm just going to mark off every pi over 2. All right, so I say here's 0. Let's say this is 2 pi over here, all right, and then we'll break this into quarters. So this is pi over 2, right, first quadrant, then pi over 2 to pi, second quadrant, angles in standard position, pi to 3 pi over 2 for third quadrant, and then 3 pi over 2 to 2 pi for fourth. And let's do that. Now you're going to see this is one cycle here. Right. And here's 1 and -1. And what I'm going to graph here first is the cosine function. Remember, cosine of 0 was 1. Cosine of pi over 2 was 0. Cosine of pi was -1. Cosine of 3 pi over 2 was 0. And cosine of 2 pi was back at 1 again. All right, so here was that wave with an amplitude of 1 and all that, right? There's y equals the cosine of x. Now, when I take reciprocals, right, when I'm doing the secant, wherever the cosine is 0, the secant will be undefined. So at pi over 2, you saw earlier, there's going to be a vertical asymptote. At 3 pi over 2, right, the secant of 3 pi over 2 will again be undefined. And then you're going to get these U shapes. Now the cosine of 0 was 1, so the secant of 0 will also be 1. And then all these values here are between 0 and 1. When you take values between 0 and 1 and take the reciprocal, you're getting values greater than 1. And so that you get this piece of picture that I already drew. Alright, so there's the right half of a U shape opening up, approaching infinity on the left side of this asymptote. Then the cosine of pi was -1, so the secant of pi will be -1, right? The reciprocal of -1 is -1. And all these values are between 0 and -1. When I flip them, they'll be less than -1, so I'll be approaching, negative infinity there, negative infinity over here. And then over here, the cosine of 2 pi was 1, so the secant of 2 pi will also be 1. And all these values are positive values on the cosine. They'll still be positive, but be greater than 1. So here I get the graph of y equals the secant of x. And what I've just drawn here, from 0 to 2 pi, is one cycle. One cycle. Alright, so this is one cycle. Alright, so the period, again, the period of secant, just like for cosecant, just like for sine, just like for cosine, the period is 2 pi. It'll repeat every 2 pi radians, or every 360 degrees. Now, this is just, again, one cycle. I could do the same picture over here, right, where I go from 0 to, say, -2 pi. Right? And from 0 to -2 pi should be the exact same picture as from 0 to +2 pi. And I break it into quarters, right, like you've seen me do with all those key value problems, right? I took my period and broke it into quarters. So every pi over 2, -pi over 2, -pi, -3 pi over 2. Again, there should be asymptotes. Again, it looks like every pi radians, at -pi over 2. at negative 3 pi over 2, right? If I'm going to draw basically the same picture as this over here, I'll have asymptotes at negative pi over 2 and negative 3 pi over 2. Then you'll finish the U shape opening up over here. And then I'll have between these two asymptotes a U shape opening down, starting at, and the highest it gets is at negative 1, right? I'm just recreating this U shape over here. So I'll have this U shape opening down between these two asymptotes. And then over here I'll have a U shape opening up, but 0, 1, negative 2 pi, 1, and then a U shape opening up, and it'll continue on that way as well. But this picture I drew from 0 to 2 pi, I just keep redrawing, every period, every 2 pi radians, right? So this is important down here, right? The period for secant of x, the period for cosecant of x, same as for sine and cosine, is 2 pi. All right, the only ones that were different, I'll say it again, the only ones that were different were tangent x and cotangent x. Remember, tangent and cotangent had a period of 1 pi, not 2 pi. All right, so now let's take a look at some different versions of these graphs, right? Some transformations. Oh, I guess, sorry. I should write up the properties here, right? The domain and range and all that. Right. So for our secant function, right? So for y equals the secant of x, right? The reciprocal of cosine. The domain is all real numbers except certain ones. I can plug in whatever I want for x except the following. It's where is it undefined? Well, look at where the asymptotes are. 1 pi over 2, 3 pi over 2, negative 1 pi over 2, negative 3 pi over 2. What kinds of numbers are on the pi over 2? Are negative 3, negative 1, 1, 3, 5, 7, 9. Odd numbers. Odd numbers of pi over 2. Except the odd multiples of pi over 2 of 90 degrees. So 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2, and so on. Though there will be asymptotes there for just plain old secant of x. Secant is undefined at those values. Now the range is the same as the range for cosecant. See, look at the purple graph again. I'm going from negative infinity up to negative 1. And then there's a big gap between them, right? There's a gap between these U shapes that I can fill with a cosine wave, right? There's a space between them where there's no outputs, no piece of the purple graph, and then from 1 upward, right? So in union with, and then from 1 to infinity, right? So the same as the range for regular cosecant x. So secant x, cosecant x, same range. Now, this graph, like cosine, just like cosine, has y-axis symmetry. Look, if I start from any point on the graph, go to the y-axis, and then go the same distance across, I'm on the graph again. Reflecting across the y-axis doesn't change the graph. And that was called an even function. Right, it had a graph with y-axis symmetry, meaning that the secant of a negative angle is exactly the same as the secant of the positive angle. All right. So there were 4 odd functions. There were 4 odd functions: sine and cosecant, its reciprocal, and tangent and cotangent that we saw last video. There are only 2 even functions, 2. There's cosine and its reciprocal, secant. And that's it. Those are the only 2 basic trig functions with y-axis symmetry. All right. Okay. So now that we got the graphs, hopefully that now that we got these graphs of the basic secant x, cosecant x down. Again, just these u up, u down, u up, these u shapes opening up and down with a gap between them, between these asymptotes. Now that we got the shapes down, we can take a look at, other versions of them, transformations. All right, so back here, let's go. Here, our first problem, this first objective I'm looking at, is find the equation of a cosecant function from a graph. So let me show you how this is done. Remember how I said earlier, this gap between them? You see I got this, u up, u down, u up, u down. Between some, the asymptotes aren't drawn here, but you can tell where they are, right? There's an asymptote at pi over 2, there's an asymptote at pi, an asymptote at negative pi over 2, an asymptote at 0, right? What I'm going to do to find the equation for this graph is find an equation for the sine wave, right? They're asking for cosecant, right? This is find an equation of cosecant. This is a cosecant they want. So what I'm going to do is I'll draw this on some paper. We're going to draw the sine wave that's between these, find an equation for that sine wave, and then just change the sign to a cosecant, right? Flip it over. Right? You'll see what I mean when I go to some paper here. Okay, so here I have a drawing of what they've given me. All right. I've labeled I put the asymptotes in at negative pi over 2, 0, pi over 2, and pi, right? The asymptotes there. This is negative pi over 4 comma 0, and then some u shape opening down between these asymptotes. This is negative 3 pi over 4 comma 2 with a u opening up, and it's u up, u down, right, between these asymptotes with a space between them, right, a gap. And I'm asked to write an equation for this. Write a cosecant function, right? Find a cosecant function with this graph, right, is what we're asked to do. So again, they mention cosecant here. You just have to remember that cosecant is the reciprocal of sine. So what I'm going to do, and what I would recommend you do, I'm going to draw a sine wave in this gap between these u shapes. And then we're gonna find an equation for this sine function, and then just change the sign to a cosecant, right? Flip it over, right? So again, where these hills and bottoms of valleys and tops of hills are on the cosecant function, will be the top of a hill, bottom of a valley, for the sine wave, right? So sine here, and then where's the midline? Right, now we need the midline, because this will be the top of a hill for the sine wave. This will be the bottom of some valley for the sine wave. Top of a hill, bottom of some valley. All right. I'm going to draw in the midline here. All right. Now this is at 2. This is at 0. So the peak of my sine wave will be at 2. The bottom of my sine wave will be at 0. The midline then is at 1. Right, so the middle of those is at 1. So here's, I'll put a little dotted line here. Here's the midline for the sine wave, right? It's exactly halfway between these U shapes. And wherever there are asymptotes is where it's going to cross the midline. So negative pi over 2 there, right? And we'll have this part of the wave like that. At 0, right? Again, so 0, 1 will be on the sine. And then pi over 2, 1, right at the midline, will be on this sine wave. And pi 1, right? And again, so I got this sine wave here. And then negative pi 1. Just drawing a sine wave. Right? Here I have just drawn a sine wave. And I would like to now figure out the equation for that sine wave, right? It's going to be y equals, now hopefully this looks familiar. Going back to section 8.1, right, we were drawing equations for sines. It was, some number a times the sine of, and then b times the quantity x minus c, all in parentheses there, and then plus some d, and hopefully you remember what all these meant. Okay, now the plus d is easy. Remember, d gave me the midline, so d equals 1. Right, I shifted, instead of having the midline on the x-axis at y equals 0, the midline's at y equals 1. So d equals 1. Remember the value of a. Now, let's just look at one cycle here. Right, I'm going to highlight one cycle, one period. Now, being that it's a sine wave, I'd like our normal sine wave, remember, started at the midline. So I'll start here on the midline. Now let's just say I'll go from here, and we'll do one cycle. So I'm going to highlight this in like a light green, a lime green here. Just going to draw one cycle, and we'll use this one cycle. There's one cycle here, right, going up, then down, then up. There's one period of this sine wave. So it's clear to me that the period is pi. Right, see how the period is pi, the length of this one cycle. And remember how you found the period. That was, for sine, you did 2 pi divided by that, absolute value of that b, right? This b number here. So b must be 2. And it should be a positive number, because notice it's just like our regular sine wave. Our regular sine wave started on the midline, then went up, then down, then up, and this is doing exactly the same thing. All right, so b is 2, right? In order to make the period pi, right, the length of one cycle, pi radians. And notice that I'm starting at 0, right? That's where c is going to give me, so c equals 0. Again, hopefully this all sounds familiar. I'm not going to go over all this again. Go back to section 8.1. Right? So the c here tells me where I'm starting the cycle from, which is 0. I've decided to start here, starting the cycle at 0. So c equals 0. And then the a, remember, is the amplitude. All right, now the amplitude's, again, pretty easy to find. It's just the distance from the middle to the top or the middle to the bottom, right? So a equals 1 unit. I'm going from 1 to 2. So a equals 1. All right, so the equation for this sine wave, all right, putting all this together, the equation for the sine wave between these u-shapes is the following. Y equals, 1, a is 1, the amplitude's 1, times the sine of, and then b was 2 and c was 0, so you just got 2x in here, 2 times x minus 0, so sine of 2x, and then plus 1, right? It got shifted up 1, the midline's at 1. So this is the equation for the sine wave, and then I just change sine to cosecant, and that'll give me the equation for the cosecant, right? It would be all the same transformations done to the original cosecant. All right. So it's again, hopefully that's easy. Then change to cosecant. So the equation for this U-shaped graph here is y equals, the cosecant of 2x and then plus 1. And you can double check, plug in points. If I plug in negative pi over 4, that'd be the cosecant of negative pi over 2, which would be negative 1, and then plus 1 would be 0, and it's negative pi over 4 is 0. If I plug in pi over 4, I get the cosecant of pi over 2, which is 1, plus 1 is 2, pi over 4, 2. This would have a period of 2 pi divided by 2. It would have a period of pi, and you see this from 0 to pi is the same picture as from 0 to negative pi. Everything's working out. And the midline is at 1, right, plus 1. So I'm getting y equals cosecant of 2x plus 1. So again, this is the same thing for secant. If you were doing if you were given the graph of a secant, these u up and u down with a gap between them, draw a wave between the gaps, right, in the gap between the u-shapes, and then write an equation for that wave as a cosine, and then change cosine to secant. Right, flip it over. All right, so here, we're asked to enter it below here. I said it was y equals, I enter CSC, the cosecant of 2x, and then outside of that, plus 1. Wonderful. And again, they do the same thing, right? They draw this, and their cycle was different than, they're highlighting this period. I highlighted this period, from 0, 1 to pi 1. No difference, right? You still end up with the same thing. Now they have a different version because they started at negative pi over 2. I started mine at 0. All right, and they flipped it, but I get the same graph. They give, as long as you put in something that would have the same graph, it's golden, right? This is actually equivalent to this. Notice it's still good. All right, so it all depends on what your cycle is. I started mine at 0. They started theirs at negative pi over 2, right? And theirs, they went down, then up, then down, instead of up, then down, then up. So that's why they had the negative number in front, right? They flipped the normal sign. So just a lot to pay attention to, I know, but hopefully if you're familiar with how section 8.1 worked with sines and cosines, this shouldn't be so bad. All right. All right. So in this one, we're graphing a secant function. I'm giving this thing here, and I'm going to do the exact same steps that I did for tangents and cotangents and sines and cosines. And do the same exact steps that what I call the key value method, what other books have called the key value method. Now you, on the other hand, you can hit on more instruction and see how they're doing it, and if you like that better than the way I'm doing it, do it their way. I don't really care, as long as you get the graph correct. Alright, so I'm going to go to a piece of paper and show you again how it's the same steps, right? The only thing you have to pay attention to is, if you have a tangent or cotangent function, then the original period is pi, and you divide by pi by a number to get the new period. If it's any of the other four, sine, cosine, secant, cosecant, then you're dividing 2 pi by some number to get the new period, right? That's the only thing you really have to pay attention for. All the other steps are exactly the same. Okay. So same steps. First is, I take the expression inside the trig function, this 2 times the quantity, x minus 3 pi over 4, and I set it equal to 0, and I solve this for x, and that'll tell me where I'm going to start drawing, right, where I'm going to start drawing my first cycle. So that would clearly be at x equals 3 pi over 4. All right, so here is where I'm going to start drawing my first cycle, right, the first period of this graph. Then the period. Now remember, the period of plain old secant, right, this is a secant graph, is 2 pi, but then this gets divided by some positive number, and that would be the number multiplied by the x inside the trig function. So here, now, if you distribute the 2, you see how 2 would be multiplied by the x? So it's 2 pi divided by 2. Right, so the period for this function is going to be pi. And that'll help me determine where I'm going to end the first cycle of my drawing. I'm going to end at x equals, where I started from, 3 pi over 4, plus 1 whole period, right, plus pi. Now that would be 7 pi over 4 when I put them together, get a common denominator, 3 pi over 4 plus 4 pi over 4, be 7 pi over 4. So I'm going to end my first cycle, again, just the first cycle, right? You can draw more than one cycle. So I'm going to start at 3 pi over 4, end at 7 pi over 4. All right, now I'm going to take this one cycle, this one period, and find all these other, key values by taking the period and breaking it into quarters. So I take, what's a quarter of the period? So that's a quarter of pi. Well, that's just pi over 4. That's just pi over 4. So this is, again, going to be the distance between each key value on the x-axis. I've said this before. I've done this in the previous 3 videos now, or whatever, on graphing trig functions. Alright, then I made a chart with these key values for the first cycle. So I said I was starting at 3 pi over 4, And then I just keep adding this pi over 4. I keep adding this quarter period until I get to the end of my first cycle at 7 pi over 4. So I add pi over 4, that's 4 pi over 4, or pi. Add another pi over 4, that's 5 pi over 4. Add another pi over 4, that's 6 pi over 4, which is 3 pi over 2. And then add another one, that's your 7 pi over 4, like I said I was going to end at. See, the distance between the first value and last value is pi, which is the period. Right. This should be a good chart for one cycle, one period. Alright, then I plug these in to my function. Alright, now again, this first example, I'll actually plug them in and show you what I'm getting. So if I plug in 3 pi over 4, well, that would be y equals half the secant of 0. Right? If I plug in 3 pi over 4 for x, this becomes 0, and then 2 times 0 is 0. Now the secant of 0, remember the cosine of 0 is 1. So the secant of 0 is also 1. So I get half of 1 minus 2, that's a half, minus 4 halves, that's negative 3 halves, right? So input 3 pi over 4, output negative 3 halves. The next value in this chart with these key values, x equals pi. I'd have y equals half of the secant of, now when I plug in pi for x, pi minus 3 pi over 4 would just be pi over 4. Oh, and then times 2 would be pi over 2. Sorry, I was like, this should be pi over 2. Pi minus 3 pi over 4 is pi over 4, and then times 2 would be pi over 2. All right, so I have the secant of pi over 2. Now, and then minus 2. Half the secant of pi. Now the secant of pi over 2 is undefined. All right. Remember the secant of those odd multiples of pi over 2? Said that earlier, was undefined. So I'm going to have an asymptote here at x equals pi. Put UND. When x equals 5 pi over 4. Plug that in. You get y equals half of the secant of. Now 5 pi over 4 minus 3 pi over 4 is 2 pi over 4, which is pi over 2, and then double that, just pi. And then minus 2. Now the secant of pi is negative 1. So half of negative 1 is negative half. Minus 2 is negative 5 halves. Negative 5 halves. And then plug in 3 pi over 2. And I'm in y equals half of the secant of 3 pi over 2. Right, because look, 3 pi over 2 minus 3 pi over 4. Well, that'd be 6 pi over 4 minus 3 pi over 4 would be 3 pi over 4, but then times 2 would be 3 pi over 2. So I have the secant of 3 pi over 2 in here. This is also undefined, because you have the secant, right? The secant of an odd multiple of pi over 2, and we said earlier that that's undefined. And you can check this last one, but if you're doing this correctly, remember the distance between the first value and last value in my chart is the period. So it should have the same output. So negative 3 halves over here. Alright, so I start plotting points and remembering what these secants and cosecants look like, right? They're these U shapes, U up, U down, U up, U down, or U down, U up, U down, U up, between asymptotes with a gap between them. So I make some axes, and I'll start marking these off. Now 3 pi over 4, the distance between these is pi over 4, so I'm going to make little notches. This is 1 pi, let's say this is 1 pi over 4, 2 pi over 4, and then let's go big here for there's 3 pi over 4. All right, and then 4 pi over 4, all right, pi, I probably should have made these bigger. 5 pi, yeah, I'll make them bigger. Nah, keep going. 5 pi over 4. Then 6 pi over 4, 3 pi over 2, 7 pi over 4. All right. Okay. Now there should be an asymptote at pi and 3 pi over 2. And the values that are showing up here are negative 3 halves. All right, so let's say this is negative 1, negative 2, negative 3. Negative 3 halves is negative 1.5. And negative 5 halves is negative 2.5. Right, so there's negative 3 halves, negative 5 halves there. And I got 3 pi over 4, negative 3 halves, asymptote. 5 pi over 4, negative 5 halves, asymptote. And then 7 pi over 4 back to negative 3 halves. Like I said, remember, there should be a gap. Don't make this u down, u up. The u shape should not overlap. So this is going to be a u up, then a u shape opening down, and then part of a u shape opening up. And this would continue on. Now, I can keep this going. So at pi over 2, right here, that would be an asymptote. It looks like there's an asymptote every other. So, I'm just going to draw this picture again over here. So pi over 2, there should be an asymptote. Then at pi over 4, we got this U shape opening up between these asymptotes. And then at pi over 4, should have a value of negative 5 halves. That part going down. And then 0 should be an asymptote. Sorry, this was too thin. These were too thin. And then at 2 pi, another pi over 4, that's 2 pi. There should be another asymptote. And then opening up like that. And asymptote 0. So here's a couple cycles. All right, you said the period was pi, so 0 to pi, pi to 2 pi, that's 2 cycles, 2 periods. All right, but I did the exact same stuff I did before, right, where I found where am I starting the cycle, what's the period, where is that first cycle going to end, take that period, break it into quarters, find the key values, plug the key values in, plot them, graph them, right? And the thing is, you just have to know what secant and cosecant graphs look like, right? They're these U shapes opening up and down with a space between them. So if I go back to the website here, now this is one of those interactive ones again. I'll even pull up my picture. This is one of those interactive ones again where I have to move some things around. Let's see how they want them to move. Drag the movable red point to shift the function. The black point to set the vertical asymptotes, and the blue point whose y value is printed on the graph at the correct set of coordinates. So let's see how this moves. So my asymptotes here, looking at these, let's see this. We're going to move the period's pi. Right, so from 0 to pi, I had an asymptote at pi and pi over 2. Oh, geez. Okay, so that doesn't do that. Let me figure this out. Okay, so it looks like you have to move the red point. See, the red point is underneath the one of the bottoms of a U shape here. So that red point I moved to here, which was at underneath the in my graph here, underneath the bottom of a U shape. There's the point 3 pi over 4, negative 2. So that's where I moved that red point underneath the bottom of a U shape, and then I move the asymptotes in to be at pi and pi over 2 around it. So you see here's pi, negative 2, and then this y coordinate here at negative 1.5 for the bottom of that U shape. All right, so you got to move that middle point. You got to move that red point around so that you're at a point on your graph that's actually supposed to be underneath a U shape here. All right, so again, kind of annoying, all the moving around, but you see it does work out. So we'll get to another one like this, I'm sure, in a second. So I'll show you the full movement. All right. See, their procedure was graph the cosine function and then just flip everything, right? But like I said, I don't really do that for graphing. I'll do it for finding the equations of a graph like this, right? Find the equations of this cosecant. So again, I'm going to draw this. I'll draw this graph here, and then we'll, try to figure out the, it's another cosecant. Right, so I'm going to be drawing a sine wave and find the equation of that sine wave, and then just changing the sine to cosecant, and it'll be the equation for this blue graph. Okay, so based on the points they gave, they gave 5 pi over 24, comma 4. They gave me 17 pi over 24, comma 4. So the points between them, halfway between them, halfway between 5 and 17 pi over 24 would be 11 pi over 24. So that'd be the the top of this U shape opening down. So it looks like the bottoms of the U's and the tops of the U's are every 6 pi over 24. So I go minus 6 pi over 24, minus 6 pi over 24, minus 6 pi over 24. So the top of this one's at negative 1 pi over 24. And then halfway between those would be the asymptotes, right? Halfway between negative pi over 24 and 5 pi over 24 would be 2 pi over 24, or pi over 12, there's an asymptote. And so it looks like all these special values here are 3 pi over 24 apart. So, 8 pi over 24 for, next asymptote, which is pi over 3. And then from 11 pi over 24, you add 3 pi over 24, it'd be 14 pi over 24, which would be 7 pi over 12 for another asymptote, and so on. So I'm using symmetry, using some nice symmetry here, I could figure out the coordinates of all these points. Alright, but like I said, we're trying to find an equation, a cosecant function. Alright, we're trying to find a cosecant function, meaning I'm going to use a sine wave, right? Cosecant's the reciprocal of sine. Alright, so I'm going to draw, now remember the mid value would be at y equals 2, right? These peaks and the bottoms and tops of the U-shapes are at 0 and 4, so they'll be at the top and bottom of the sine wave that I draw in between. So 0, 4, halfway between them is 2. Right, the midline is at 2 here. And when I go to draw the sine wave, it'll be like, start down here, then it would have pi over 12, comma 2, and then 5 pi over 24, 4, and then pi over 3, comma 2, and 11 pi over 24 is 0, and 7 pi, it's just going to go up and down and up and down and up and down. Got this sine wave here, but in the gap between the U-shapes. And it would continue on like this, on like that. So I got a sine wave. Now you could also think of it as a cosine wave and draw a secant function, but they asked for a cosecant though, so that's why I'm using sine. Alright, and then what part of this do I want to look at, for one cycle? Well, I like to start at the midline. Remember how I normally would love to start our sine at the midline, so I'm going to start here at the midline. And it's like the original sine, y equals sine x, where it goes up, then down, then up. So I'm going to do, here's one period. Right, there. Up, then down, then up, and back to the midline. There's one full cycle, one full period of this. Alright, so the period of this function, it's from pi over 12 to 7 pi over 12, right? The beginning of this to the end of this. That's 6 pi over 12, which is pi over 2. Alright, so remember how that was found? It was, it's a sine wave, cosecant, so it was 2 pi divided by the absolute value of b. Alright, so b must be 4. That b must be 4. When I'm trying to write an equation for the sine wave, y equals, again, a times the sine of b times the quantity x minus c, and then plus some d. Now we know the midline's at 2. Alright, so d equals 2. The plus d, we know that midline's at 2, so d equals 2. We said, we know the period is pi over 2, which is 2 pi over b. So b must be 4. So there's a 4 there, 2 there. The c is where I'm starting the cycle from, which here is at pi over 12. Right, so the c is at pi over 12. See, where I started this one cycle I looked at. C is pi over 12. And then a is the amplitude. All right, now from the top to the middle here is 2 units, from 4 to 2. So a is 2. So the equation for this sine wave The equation for this sine wave I've drawn between the u shapes is the following. Y equals, amplitude 2 times the sine of b is 4 times the quantity x minus pi over 12, right? C was pi over 12, and then plus 2 plus the 2 afterwards. Now I'm going to distribute the 4 here. So we have the equation for this sine wave is 2 times the sine of 4x minus pi over 3, and then you have plus 2 after. And then I'm just going to, this is the equation for the sine wave, and then there was the cosecant would have been found with the exact same transformations. So let's change sine to cosecant, and I'll get the graph of the equation for my purple graph, right? The u up, u down shapes. So it's changing this to cosecant, sine to cosecant. We get y equals 2 times the cosecant of 4x minus pi over 3, and then plus 2 after. Right, there's the equation for that purple graph, or the blue graph that I started with back in the assignment. Right, so again, drawing a sine wave or cosine wave if they're asking for a secant, and then figuring out the equation for that sine wave or cosine wave like back in section 8.1, and then just changing sine or cosine to cosecant or secant respectively. All right, so we have y equals 2 times the cosecant of 4x minus pi over 3. That was after distributing, right? And then afterwards plus 2. All right. Now again, my answer may be different looking than theirs because they might have started their cycle somewhere else, right? But it should be equivalent. All right, yeah. So yeah, they started their cycle at pi over 3. So you see how they're going to have eventually see how they have the x minus pi over 3 over here, and they had negative 2 because where they started the cycle it went down then up then down instead of up then down then up like a normal sign would, so that's why they flipped it with a negative sign. Mine is totally fine. The graph of mine is exactly the same as the graph of theirs, right? As long as you're entering something equivalent, it should be fine. All right. So this is graph a cosecant function this time, and then move the stuff around. So this time again I'm going to do this and move my dots around, and I'll show you how to do all that as well. Okay, so here's the cosecant function they gave me, and I'm going to start my cycle at x equals negative 3 pi over 4. That'll make the inside 0 there, this expression inside. The period is, this is a cosecant function, so it's, the normal cosecant is a period of 2 pi, but that gets divided by 2 here. Right, so the period is just pi, meaning the end of my first cycle on that chart I make will be at x equals, negative 3 pi over 4 plus pi is positive 1 pi over 4. And then what's the distance between each key value, right? A quarter of the period is just pi over 4, right? So this will be the distance between all my notches. I make a little chart. Right, I start at negative 3 pi over 4, and I'm just going to keep adding pi over 4. So negative 2 pi over 4, which is negative pi over 2, negative 1 pi over 4, then 0, and then positive 1 pi over 4. Plug these in. Now this is cosecant. Remember, cosecant's the reciprocal of the sine. When I plug this in, cosecant of 0 is undefined, right? Because the sine of 0 was undefined, so I'll have an asymptote there. When I plug in negative pi over 2, this whole thing inside here should simplify to positive pi over 2, and the cosecant of pi over 2 is 1, half of 1 is a half, plus 2 is 5 halves. Plug in negative pi over 4, I get the cosecant of pi, which again would be undefined. The sine of any multiple of pi is 0, so the cosecant of any multiple of pi is undefined. Plugging in 0, I get cosecant of 3 pi over 2, which would be negative 1, negative half plus 2 is positive 3 halves, and then again undefined. So lots of asymptotes here. So let's see, let's say this is pi over 4 here, and then we got 0, and then negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. Right? Here's the one cycle in my drawing. in my chart, and then I asymptote here, asymptote here, asymptote here. The outputs are at 1.5 and 2.5. So here's 1, here's 2, here's 3, here's 5 halves, here's 3 halves, and we got negative pi over 2, 5 halves, and then 0, 3 halves. Again, knowing that this is a cosecant function, these are going to be these U-shapes opening up or down, but they can't overlap. I can't have this one open down, this one open up, because then there'd be an overlap. Remember, there's got to be a gap between them. So this one's got to be the one opening up between these asymptotes. This one's got to be the one opening down between these asymptotes. All right, so clearly the midline is at 2. Again, midline is at 2. I'll keep that in mind when I go move my points around. All right, so let me go move these points. So back on the website, you're going to be moving the points around. I'll pull my graph up again. And yeah, so see this midpoint, this red point, I'm going to move that first this time. See how this is between a U-shape opening down and a U-shape opening up? I guess I could flip it. And yeah, I'll flip it because I want to set it up so I have a U up and then a U down. So I'll put this midpoint here, right here. I'll put it at negative pi over 4 comma 2, right? That midpoint between a U opening up and a U opening down. I'll put this red point at negative pi over 4 comma 2. Move this up here. Pretty sure that's where that is. Negative pi over 4 comma 2. Great. All right, then the asymptotes. Now this is at negative pi over 4. I want the other one to be at pi over 4. All right, the next one. There. Beautiful. All right, that's at pi over 4 comma 2 right there for this other asymptote. Hopefully then this is at negative 3 pi over 4. It looks like it. And then just make sure that this blue dot is at positive 1.5, positive 3 halves right there. Beautiful. There's my graph. All right. You see from negative 3 pi over 4 to positive pi over 4, I get the exact same picture I drew here, a U up and then a U down. Let's submit. Oops, what did I mess up on? This is at pi over 4. This is at negative pi over 4, 2. This is at 0, 1.5. What's wrong here? This is negative pi over 4, 2.5. Negative pi over 2, 2.5. Alright, I'm going to read into this and see where I messed up. Sorry. Alright, so I think I know where I went wrong. It says make sure to move the points in the direction of the phase shift. So the phase shift would be at, I remember how I said start at negative 3 pi over 4. So I should move this red point over, as it said, drag the movable red point to shift the function. The phase shift was 3 pi over 4 to the left. So instead of being at negative pi over 4, I should have this red dot at negative 3 pi over 4, comma 2, and then all these other points should be good. Let's see what happens. Oh, what happened? Alright, let's see what their answer explanation is. Answer 1, answer 2. Oh yeah, that's I moved it over, but I forgot to switch the U ups and U downs. Right, look at my drawing. Yeah, my bad. I moved this over here. I moved this over here, but I didn't switch the U down to a U up like I have in my drawing. Alright, so I just wasn't paying close enough attention to my drawing. So there's a lesson there for you. Alright, that's a little annoying, but pay attention to the drawing because everything else is correct. I moved the phase shift, everything else is correct. I just didn't move the red point to the right spot, and then when I did move the red point to the right spot, I forgot to switch them back to U up afterwards. All right, so let's move on then. My apologies. Alright, so this is a secant function this time. Alright, so remember, for a secant function, I'd be graphing a cosine. Alright, I'd be graphing a cosine. So I'll draw this one. Alright, I'll draw this one. Alright, so I've drawn, now they gave us the points negative pi over 3, negative 2, and then this, U shape opening down. They also give us pi over 6, negative 2. Alright, so this other point at the bottom of the U up here must be halfway between. Now halfway between negative pi over 3 and pi over 6 is negative pi over 12. So that'd be the point negative pi over 12, 4. And that also means the distance between these is, pi over 2. The period's pi over 2. Alright. But we'll get to that when we draw a cosine and all that. So that's where I was getting all these values from. And then I just broke it up and drew more and more pieces of the picture. Alright, so we're asked to draw a secant now. Alright, we're asked to write an equation for a secant. Now remember, secant's the reciprocal of the cosine. So when I draw a wave here, now let me draw the midline as well. Alright, now the midline, this point's at negative 2, this point's at 4. Halfway between negative 4 and 2 is 1. Alright, because there's 3 above and then 3 below. So you got the midline here is at y equals 1. Alright, so I'm going to draw a cosine wave, just like I did for the secants and cosecants and sines. I'm doing for this secants and cosines. So this point here, and at the asymptotes is where I'll cross the midline. This point here, asymptote midline at pi over 20. This is negative 5 pi over 24, pi over 24. I missed all these points here. Okay, and we're drawing the cosine wave. And I can do this forever, but in that little gap between, the u ups and u downs. Alright, so again, I'm treating this as, I know it's just like a sine, right? Sines and cosines are the same, but here's a cosine wave. And I want to find the equation for that cosine wave, and then just change cosine to secant to get the equation for my purple graph. So just like the sines, y equals a times the cosine of the quantity b times the quantity x minus c, and then plus d. Now the midline's at y equals 1, so d equals 1. Alright, now let's take a look at a cycle. Now my normal y equals cosine x, right, the usual cosine, starts at the top of a hill. So I'm going to start it up here at the top of a hill, and then it goes down, then up, then down for the normal cosine. Right? So I'm going to look at this cycle right here, right? There's a full cycle of a cosine wave, down, then up, then down again. So that's from negative pi over 12 to 5 pi over 12. That's 4 pi over 12. All right, that's 4 pi over 12. Nope, that's 6 pi over 12. Silly. Negative pi over 12 to 5 pi over 12. That's a difference of 6 pi over 12. So the period, right, the length of this one cycle here is 6 pi over 12, which is pi over 2. Now remember how a period was found for these transform functions. It was, if it was sine or cosine or secant or cosecant, it's 2 pi divided by some positive number b. So in this case, b would then have to be 4, right? 2 pi divided by 4 would be pi over 2. So b is 4, d is 1, right, the midline. C is where the thing starts, where the cycle start from, negative pi over 12, right? So C equals negative pi over 12. And then the A is the amplitude, and again, I started here, so it's like the usual cosine, starting at the top of a hill and then going down, then up, then down. So I'm going to have A be positive if I started it at the bottom and then went up and down, then up, and I'd have A be negative. But the amplitude here is 3. From 1 to 4, right? 3 from the middle to the top. Alright, so using all this, we have an equation for the cosine wave that I've drawn in between those U shapes. Y equals 3 times the cosine of 4 times the quantity x plus pi over 12. right? Because c is negative pi over 12, minus negative would be plus pi over 12, and then plus 1. And I like to distribute the 4, so we have 3 times the cosine of 4x plus pi over 3, and then plus 1 after. That's the equation for the pink graph in between, right? The cosine wave, and then I just changed cosine to sine, right? Because all the same transformations would have had to occur to the secant function. I'm sorry, I changed cosine to secant. All right, so now I just change this cosine to a secant. Y equals 3 times the secant of 4x plus pi over 3, and then plus 1, right? And there's the equation for this purple graph, right? The graph that they gave us in the assignment. So y equals 3 times the secant of 4x plus pi over 3 and then plus 1. Alright, this is looking, gosh darn it. If you read the directions, wants me to put it in this form. Alright, so see the form here. If I view the answer, they got it. Alright, so I should have had, now they might have a negative. Come on. Okay, now see this time they actually specified they wanted it this way, where they, you know how I distributed the 4? They didn't want that, so they don't distribute anything here. And if you look at their picture, they start the cycle this way. Start here, go down, then up, then down. So that's why they got negative 3 in front instead of positive 3. The start of the cycle is at negative pi over 3. So you can make this x plus pi over 3, x minus negative pi over 3, or x plus pi over 3. And the period was pi over 2, so the b was 4, and then you got the plus 1. Like everything's this. I did the same thing, it's just I didn't enter my answer this way. Alright, so I should have technically had 4 times the quantity, x minus pi over 12, or minus negative pi over 12, or something like that. Alright, so let me do another one. Hopefully another one will come up like that. And this time, I'll just say it out loud. So they want a secant again here. Secant. So if I started the secant wave here, can you, hopefully you can see my cursor. If I trace out a cosine wave, starting from here, then going up, then down, then up. See, it's starting at negative pi over 3. It's going up to here, then down. That's the opposite of the way I would normally like cosecant to go. So I'm going to have a negative number, and then what's the amplitude would be, its lowest point is at negative 4, its highest point is at 2. That's a distance of 6, so the amplitude's 3. So I'm going to have a negative 3 in front. Right, I'll put negative 3 in front. Now you see this time it just says provide your answer. It doesn't say put it in any specific form. So I guess you really got to pay attention. Provide your answer below, and it doesn't ask me to put it in any specific form. So I could distribute this time. The last time it told me to put it in a specific form. So I guess the lesson here is, and it's been a big one, is to really pay attention to the instructions. Because I fudged up on a couple instructions here and got things wrong. So I have negative 3, again because of down, then up, then down, times the, that's a secant, right? They said want a secant of the period, right? This is the whole cycle here from this dot to this dot is one cycle from negative pi over 3 to 11 pi over 3. That's 12 pi over 3, that's 4 pi. 2 pi divided by what would be 4 pi? Well, 2 pi divided by a half, so I'd have a half out here times the quantity x minus, and then where am I starting with that pi over 3? So x plus pi over 3, right? X minus negative pi over 3, where I'm starting at this dot. So x plus pi over 3. And then where's the midline? Right, the midline, well, if the bottom is at -4, the top of the wave is at +2, halfway between those would be at -1. So plus negative, I put -1 after. So I mean, you could reason it out without drawing it. And again, pay attention to the instructions. Right, the instructions tell you how they want the answer. This one just had provide your answer. The last one had write it in a certain way. So I guess just to be safe, write it this way, where you have, a times the secant of b times the quantity x minus c, and then plus d after. Okay, so that's a lot better. All right. So I mean, my last one wasn't wrong. I just didn't enter it the way they wanted. All right, so pay attention. This has turned out pretty rough. I apologize. But yeah, big lesson out of this. Just pay attention to how they would like the answers entered. Alright, so this one's graphing again. Alright, so see, move the point to where it would be in the shift, and the phase shift here would be at pi over 4. Alright, so if I'm going to move this red dot over to where we're at positive pi over 4. Right there. Right, that's it. Yeah, that'd be pi over 4. Right, because it would be a positive pi over 4 that makes this inside 0. So the shift's pi over 4. So I move the red point to pi over 4. Have an x-coordinate of pi over 4. Then the period would be, 2 pi divided by half would be 4 pi. So I'm going to make sure that a whole cycle has a length of 4 pi. Now that means that this middle asymptote should be at 5 pi over 4 then, right? Because I want the distance between two asymptotes to be half the period, and this is at pi over 4. This is at 9 pi over 4. Yeah, that's 2 pi, right? 8 pi over 4, that's 2 pi. That's half the period. And then outputs would be, instead of the hills being at 1 here, right? You see how this is at output of 1, and these have an output of -1. Everything gets shifted down 1 unit. So I'm just going to shift this down 1 unit. I guess I should shift the middle down 1 unit as well. Shift everything down 1 unit. Okay, there we go. And let's see, that should be good. So yeah, cosecant. Yeah, this should work out. Yeah. Again, you can draw it by hand. I'd recommend drawing it by hand, but pay attention to how they want things. This red represents where the midline is. And they want you to put it where the phase shift takes you, so pi over 4, and make sure the distance between asymptotes is half the period, right? Because remember, you see it takes two sets of asymptotes to get one full cycle. So the distance between one pair of asymptotes should be half the period. And then this what's being added or subtracted afterwards tells you the vertical shift. All right, so let's do that again. This time it's a secant though. All right, so I see the shift, the phase shift would be -3 pi over 4. So I'm gonna move this here to -3 pi over 4. It should be right there. Right. Okay. Shift things. Things are gonna get shifted up 1 unit. There. Move the red dot up 1. Now the midline's at 1. See, and the period again would be 2 pi divided by a half. The period would be 4 pi. So the distance between asymptotes should be 1 pi. So right now, this is at -pi over 4. Let's give it that. This is at -pi over 4. And this is at -5 pi over 4, it looks like, because each notch is like pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 5. So negative pi over 4 to negative 5 pi over 4, that's 1 pi. So things are looking good for that on that end, right? Oh no, they should be 2 pi apart, shouldn't they? Right, because the period's 4 pi. So let's spread this 2, and now they're at pi over 4. Now they're at this is at pi over 4. And this looks like it's at 7 pi over 4. No, 9 pi over 4. That looks like it's 2 pi. It looks like they're 2 pi apart, making a total distance of 4 pi. Right, yeah, negative 2 pi is at the very right. All right, so this looks good. These asymptotes are 2 pi apart, so one full cycle is 4 pi. And then you get the times 3 plus 1. So if I take a usual output of 1 and multiply by 3 and plus 1, this should be at an output of 4, then 3 times 1 plus 1. Yeah, wouldn't be flipped because you're multiplying by a positive number. So this looks like it would be good. Again, I would draw it by hand if I were you first, and then try to match your picture up to the graph there. Again, this is similar where phase shifts at negative pi over 2, so I move this red dot over to negative pi over 2, move it down 3, so the midline's at negative 3, and then the period would be pi, right, 2 pi divided by 2, so the distance between each asymptote should be pi over 2, right? Right now the distance between each asymptote is pi. The period is 2 pi right now. I want to cut that in half. So there. Right now the distance between each asymptote is pi over 2. The whole period is pi. And if I take a normal output of 1, multiply it by 2, and subtract 3, that normal output will be at negative 1. Right? Okay, would it be that? Now if I do this, oh yeah, negative 1 I said, negative 1, there. Normal output, negative 1 for this first U shape with the blue dot. And it's multiplied by a positive 2, so these U shapes shouldn't flip from the usual cosecant. Again, I would recommend trying to draw it by hand first and then match your pictures. Okay, here, negative pi over 4, pi over 4, phase shift left, so I move this to the left one, the negative pi over 4 here. There'd be a down 2 movement, right, so the midline should be at negative 2. The period would be 4 pi again, right, 2 pi divided by a half. So the distance between a pair of asymptotes should be 2 pi. So right now its distance is pi. Move it here, so the distance between them is 2 pi. And then if I take my usual output of 1 for this first U shape, this first blue dot, multiply it by 4 and subtract 2, there'll be an output of 2. So there, put an output of 2 and nothing got flipped. Great. Right. So you see it can be quick if you know what you're looking at. But still, a first time through, I would recommend trying to draw these things by hand and then looking at the pictures. Alright, so here, 3 pi over 4. Move the red dot to 3 pi over 4. And there we go. There's a shift down 1, so the midline should be at negative 1. There we go. Period's still 2 pi, so I'm going to leave things the way they are. The period was already 2 pi to start. Looks like the period's 2 pi here. Okay. And then if I took my normal output of 1 for the blue dot, multiply it by a half, subtract 1, it'll be a negative 1/2. So make sure this blue dot has an output of negative 1/2, and I think this should be good. Alright, so yeah, takes some getting used to. Another one, secant this time. So again, pi over 4 phase shift, so move the red dot here to pi over 4. Up 1, right, the plus 1 there, so move the midline to positive 1 with the red dot. Period's still 2 pi, it already started off as 2 pi, I don't need to change the asymptotes. And then 2 times 1 plus 1 is 3, so this normal output for the blue dot here should be at 3. Again, please draw it by hand, practice that. Alright. And then I'll just kind of cheat these because you've seen these. Right now, notice it just says provide your answer below. Pay attention. It doesn't say set it up in any particular order, write it any particular way. I'm just going to do an instructor cheat here because, like I said, I think I would just be safe and enter it this way without distributing. So you need to know the amplitude, the period. Again, try to imagine a cosine wave or a sine wave in there, depending on what you're asked for. Alright, like they draw, look at a cycle. Alright, maybe I'll just do one more of these where I actually talk it out. Alright, so say find the cosecant, and again, just provide your answer below, so no particular way. So imagine starting, now this is a cosecant, right? So drawing a wave here. Now this is going down, then up, right? Now the normal sine wave starts at the midline. Now the midline here, we have 5 at the top, -1 at the bottom. So the midline would be at 2. And let's see, this is at pi over 12, this is at 13 pi over 12. Halfway between those would be 7 pi over 12. And then halfway between 1 pi over 12 and 7 pi over 12 would be 4 pi over 12, so at pi over 3. Right. So I start at pi over 3. Amplitude is 3. Right. Amplitude is 3. And I'm going to make it negative because it'd be going down, then up, then down. So I'll have -3 times, and then the sine becomes a cosecant. The period here I mentioned, right, pi over 12 to 13 pi over 12 is pi. So that b needs to be 2, right? So 2 times the quantity x minus, and I said it was, if I was looking at this as a sine wave, it would be, and starting at the midline, it'd be starting at pi over 3, right? Positive pi over 3. So I got 2 times x minus pi over 3 there. And then the midline's at 2, right? I mentioned the midline's at 2. Right, because we're going from -1 to 5. All right, and this is in the form that I would recommend just keeping things in, I guess. All right, cool. So you see, it's like I know what I'm doing. It's just didn't read the instructions as closely as I should have. And like I said, I would just recommend writing. I guess I would say write all your answers in this particular form, just to avoid the possibility that they might have some instruction that you didn't read. Alright, and then a similar thing here but with a secant. Alright, so I'm just going to do instructor cheat on this one. Again, imagine there's a little cosine wave in this gap here, and figure out the equation for that cosine wave, and then just change the cosine to secant. And that would be the reciprocal function. And I got all this here. Alright, so sorry about the length of that. It's because I got a couple wrong. That's why it took a little longer this time, but it's the way it is when you get more wrong. Here's another one like that. Again, I'll just do the cheat. You can look at that and take a look at this and figure it out. But yeah, that's what happens when you get stuff wrong. Right? It takes you a little longer, gives you a few more problems. I guess the biggest lesson, like I said earlier, the biggest lesson to take away from this video is to read your instructions carefully, more carefully than I did, and don't rush things. I know I was kind of rushing stuff at the end there, but when you're working on this, don't rush it. Try graphing these things by hand first, and then comparing your picture with the picture on the screen, and making sure all all the things are correct. You know, your amplitudes for the sine wave or cosine wave, the period where a certain cycle is beginning, what's the phase shift, what's the vertical shift, where's the midline of the wave, and all that. Lots of stuff to keep track of. But I know if you take your time, like I actually learned to do throughout this video, if you take your time and read the instructions carefully and follow them carefully, shouldn't be so bad. Alright, so hopefully this was a decent guide for you. Again, I apologize for some of the ones I got wrong, but hey, that's going to happen once in a while. Nobody's perfect, not even me. Definitely not me. But still, hopefully you can use this as a guide to help you through your own assignment, section 8.2, part 2. And let me know if you have any questions, of course. And thank you very much for watching.